Hello and welcome to the third WIllingdon Observatory live lockdown astronomy broadcast number 3. Tonight I'm planning to look at the moon and then hopefully look at some comets. That was suggested in a comment on one of my earlier broadcasts, so we'll see what happens. First of all, that's me in my observatory. Red lights, of course. Red lights don't affect your night vision the same way, although I've got a laptop in front of me, so sort of destroys it anyway. As usual, I'm using the same sort of gear to view these objects tonight. So there's a picture of it at night. We just go to daytime picture. You can see that we've got a couple of scopes there and cameras attached to them. That's a guide camera as well, and another finder scope. And there's a Raspberry Pi attached to the mount. So just to show you on here, you can see, so we've got an ATIK Infinity CCD camera. And that comes with some ATIK software that allows you to live stack on the fly, which is a really useful thing to do. Good for this kind of broadcast. It's on a large apochromatic triplet refractor, 5-inch refractor, so that's quite a good telescope. On the top of that, we've got the guide camera and guide scope. I may or may not use that tonight, that depends. Depends how quickly the exposures are that I'm taking with the ATIK. On the other side of the dual mount, I've got a TAL 8-inch, 200mm Kletsov Cassegrain f8.5, and on the back of that I've got my Canon EOS 1100D DSLR. And then on top of that there's a finder scope, although it's the finder objective and covered at the moment, so you can't see the eyepiece. Then you can see the EQ6 mount on top of my pier, and I've got a Raspberry Pi velcroed to the mount. The Raspberry Pi is doing running a lot of the software for the telescope. It doesn't actually run the ATIK Infinity software because that runs on my laptop, but all the software to control the mount and the guide scope, and generally the cameras on the telescopes, I run through my Raspberry Pi. Anyway, we'll immediately jump, he says, hopefully, to the moon. I've already aligned on the moon, and we've got the ATIK Infinity camera running. So let's just get to that. So here we are. So this currently is the moon, of course. I've flipped it in X and Y over here, so that it looks the same as you would actually see it with the eye. Of course, through some telescopes, it reverses it or flips it in both or one direction, just to confuse people when you look through the scope. So in this case, north is up. The standard way for looking at the moon is south is up. Rather weird. The moon is very bright, although this is first quarter moon, approximately. So that means first quarter, so the terminator is about the middle of the moon. You can see from here the exposure time is currently running at 1,000th of a second. The camera's quite sensitive, and the moon's quite bright. So that's why the exposures are currently on that very, very short. I think they're as short as it'll go. And that's just because the moon is so bright. Sometimes when you look through a telescope at the moon, you actually put neutral density filters on to tone it down, because it is so bright. This is the Infinity software running in a Windows 10 window on my Mac. Although I'm not stacking at the moment, because there's a stacking option. I don't need to stack these really. And although you can see every image is slightly different. It wobbles a little bit. It is actually moving slightly because I've not got it set to perfectly accurate for polar alignment. It is tracking, but you can see the atmosphere causes wobbles. The more you magnify, this isn't very magnified, of course, because I can't change the magnification because telescope focal lengths are fixed. So that's one of the things with telescopes. It's not like looking through a camera zoom lens where you can change the focal length. Normally they're fixed. But if you zoom in a lot, you get this atmospheric disturbance a lot more. It just does look rather weird when you see it. It makes everything wobble. So it's not too bad. So if you have some of the C's on the moon, so these black dark patches are basically called C's or mares. Mare being Latin for sea. Basically, they're lava plains which haven't been bombarded too much with meteorites yet. If you look elsewhere on the moon, you see lots of meteorite craters all over. These are more recent, so they haven't been hit by as many meteorites. Therefore, they don't look as battered. They look a lot smoother. Meteorites have hit them. If you depending on what scope you're looking through an eyepiece, if you zoom in a bit to some of these mares, you will see craters in them, just not as many as in other areas. These are like mountains on the moon, and you can look at apps and find out what all the craters are called. Every crater's got a name normally, and many famous people have a crater named after them, and some not quite as famous people have craters named after them. Anyway, so that's the moon. So as we can see, you can't see half the moon because it's in shadow, but it is there, of course. As the phase of the moon changes, this area here, which is they've got this line. I call it a line. It's not actually a line, but it's called the terminator. So this is where the sun is shining from over here, directly at the moon. So that's the sun's rays don't get around that side of it, which means you get long shadows near the terminator. The long shadows make out more detail, so because you get longer shadows. Over here, where there aren't any long shadows, you don't get very much detail. So looking at the moon when it's full isn't very good because there are no shadows presented. When it's in phase, it's better to look at. And there's some objects on the moon you can only see at certain times, depending on what the phase is. Okay. I've said it's on a setting here, automatic adjustment. The software will do automatic adjustments. It's not quite as important for a bright object like this. Deep sky objects need more adjustment. The big thing here was I had to change the saturation to get the colour a bit more like you would actually see. Okay, so that's looking at the moon. So the next thing we'll do is go and look at, well, we'll try and find first, a comet. So if I go back to my software, not that software, what I want to do is go to this software. So now I'm in my browser, and this is actually talking to my Raspberry Pi. It runs some software called Astronomy on it. A guy has created an image that you install on the Raspberry Pi, and it has a lot of astronomy software built into it. The main one being K-Stars. So I'm running this thing called K-Stars. K-Stars has some, I'll call them plugins. They're not plugins, they're part of the product, but one of them is called EAS there. And this can do things like run your mount, it can run your cameras, it can do run your guide camera, it can run a finder, it can run your dome, and it can do plate solving as well. So this is a way to find things. So what I want to do now, so currently I'm on the moon. There we are. This target's the moon. Make sure it's still synced on the moon. And then what we'll do now, we'll find a comet. So if I change my object here, so we've got C. Let me type correctly. C/2019 Y4 Atlas. Now this is interesting because Comet Atlas was of course one that was going to be very bright. However, a few days ago it was discovered it had broken up on its way past the sun. As you can see now, so rather than being one item now for Atlas, there are now A, B, C, and D. So there are actually 4 or even 5 items defined. They're all very close together, of course, because it broke up. So what we'll do is we'll attempt to find one of them. So I do a go to. You can hear the telescope move. So the telescope's moved. Let's see if I can move the star chart around a bit. There we are, there's the star chart. So that's where it thinks the, oops, move it too far. There's where the mount is currently. Okay, so the next thing to do is to move my dome. I have to do that manually. I haven't got a motor on it. So let's just stand up and rotate it. Squeak, it's a bit squeaky. I of course have to make it so that both the main scope and my guide scope, which I'm using for alignment, can see through it. So now we go to this a second. So this is the guide scope. If I now take a 5-second exposure through the guide camera, just do a capture, just to show what's out there at the moment. Make sure we can see something. So that's the current picture through the guide scope. And what I will do now is I shall now plate solve using, make sure I'm on the right scope and whatever again, capture and solve. So it'll now take an image. And I'm actually plate solving, I say offline, so actually on the Raspberry Pi. So it's taken an image, so here's the image is taken. The plate solving software will now match that against the database of stars. It took it 10 seconds to plate solve it. So it's now moved the scope to get a more accurate fix. It's taking another picture. And then hopefully when it solves that, it'll be a lot closer. I've got an accuracy of 30 arc seconds set up here. So it's not quite made it. It's 74 arc seconds away, so it'll try again. It's going the solver again on this second image. So now it's on 15 arc seconds away, so that's close enough. We've got the green sign here. So presumably in the middle here is the comet. Now comets move against the background sky, so it's faster than the stars. So let's go back to our software here. All right, so let's now take a 5-second image instead and see what happens. As long as something happens, I'm happy. All right, so we got something. Okay, so there's a 5-second image. Let's see what we can do here. So I want to change all of these settings back to standard again. Oops. Oh, I think that probably there is going to be the comet. Let's right, so what we'll do now, rather than 5 seconds, we'll take 10-second exposures. play with these settings a minute to see what might be. We'll also start stacking the images. Yes, I think we have it, don't we? So what we're doing now, we're taking 10-second images. You see all these, this is called noise in the background. All these dots are stars, of course. But all of this speckled background is noise. All cameras produce noise. Of course, the longer the exposure, the more noise you get, generally. If you cool a camera down, the less noise you get. But if you stack pictures, you can start to remove the noise. The more pictures you stack, the more noise you remove. So here we are, we're going away now, we're stacking. We've stacked 6 images at 10 seconds each, so that's just 60 seconds. Quite often when they stack the images, the background starts darkening. It doesn't darken very much yet. I think we've definitely got the comet there. Or comets, because of course it's broken up now. So they think it's in 5 pieces, I think, at the moment. I would have expected the background to have gone quite a lot darker by now. So I'm going to try instead, which means it will take longer, over to 30-second images. And I'll reset. Is it taking an image? Who knows? Let's just stop it a second. So let's set 30 seconds, winning one, start. See what happens. Yes, so the bar's moving slower. As you can see, there are many stars in the background. Sometimes you can take images and there's very few stars in the background. Well, here we are, lots of them. Once notice is starting to stack properly, we'll go and have a see what part of the sky we're looking at. Aha. Right, so there we are. Yes, that's the first image after 30 seconds. So slowly, the comet will move across the sky compared to the stars. So that's an actual challenge for taking astro images of comets. Because as they move, generally you want things to be still while you take long exposures. If things move, then basically they get blurred or trailed. So in this case, we've got the scope is tracking, so that means the stars are stationary, but the comet will be moving. So what that will mean is the comet will actually be slightly blurred or trailed in the images. It is possible to stack them with some other software which does a bit of magic. It stacks it once with the stars stationary and then stacks it again with the comet stationary, and then it merges them together, which is actually a really neat way of doing stuff. You know, I'm not auto-guiding at all, so this is just a tracking scope. So the stars are relatively round, so that's not too much of a problem at the moment because 30-second exposure isn't too long, really. As we can see the a comet's popping out slowly. So what I was going to do while that's running along is we'll go back to the software, the astronomy software, which is my browser. Let's just drag that out of the, oh no, I can do it this way, can't I? I can just go, oops. I think I can do that. Yep. So here we are. So that's where the map thinks it is. If I zoom in on this, this is K-stars now. So this is showing us, I'm just going to do something there. I just want to sync it. Now I can't actually see many stars in there at the moment. See, look at that, zoom in a bit, not many stars there. But that all depends on the software. Some software has different, could be one reason why, look in the wrong place. Let's go back there. Let's find them out instead. So if we zoom in now. It's showing a depiction of the comet there. But there's very few stars around it. That all depends on the star catalogue that the software is using. Different software uses different star catalogues and different levels of star catalogue. One of my favourite planetarium programs is Stellarium. This runs on Mac, PC, Linux, more or less anything, and it's free. So just run up Stellarium. So here we are in Stellarium. If I now find, a second, oops, what's going on? Right, let's do this. Right, so we want to find C 2019 Y4 Atlas. So this is where it thinks it is at the moment. If I zoom in on here, see I've got a few more stars on this one. And this is interesting because it's showing us the way that the various pieces of the comet are split up. So see they're all in a row. I'm not sure how far apart they're and which direction they're going in on this image. There's a lot more stars around here. So it's a different star catalogue than the other application. Stellarium uses lots of CPU. So anyway, so there that's a depiction of where all the points are. So let's quit Stellarium. And we'll zoom back out of that a bit. And we'll go back to the Infinity software. See how far we've got. We can even see a bit of greenish colour down. I mean, quite often comets show green colour. Comets have two tails. They have a dust tail and an ion tail. The ion tail is affected by the solar wind, so that's always directly away from the sun, whereas the dust tail is basically the path or the orbit it's been taking. So that's quite nice, actually, that. You can see sort of a bit of something funny happening here. What's happening, because this software actually does a, let's find the option on here. It says calculate image movement. So we've got it ticked. What that does, that matches stars from frame to frame. And so if a frame has moved slightly, it still matches the stars, but the rest of the frame could have moved. So that's what this little bit here is. That's quite a nice image, that. I'm quite impressed with that. So that there is Comet C2019, sorry, Y4 Atlas, and it's A, B, C, and D, and F. A, B, C, D, E, F, yes. A, B, C, D, E, get it right. So there's 5 bits of it at the moment. I mean, we can't distinguish that on this scope, of course. But that's a nice view. So what we'll do, I mean, the longer the exposures and the more they stack, the better the image will become. I mean, we're still getting noise in the background. We're not taking very long exposures, and it's quite a warmish night, so that affects how much noise there is. We take like maybe 2-minute exposures or 3-minute exposures, we'll probably get a better image again. But this is the software here is built for getting an image quickly. It's not for spending 2 hours imaging something, it's for spending a few minutes at most. So at the moment we've done 390 seconds here, so it's less than just over, well, just 4.5 minutes, 5.5 minutes, 6.5 minutes. So not long really. It's good. So what we'll do, we'll save that for posterity so we can publish it in our Society magazine. So let's save this. So we'll save it as a JPEG, yes. We'll save it. Where do they want me to save it? We'll save it in. I can do that. This is clever, isn't it? Right, so I'll open that up. Okay. Yep, we'll just give it. Oops. See, 2019. Now we can put a slash on here because Windows will go balmy. Y4 less. Okay, so we'll save that. That's pretty good, that. Okay, now this comet has actually dimmed quite a lot from what it was. As I said, it's going to be very impressive. Apparently that's not very impressive, but it looks pretty impressive to me. But it has dimmed, and it's not going to be as impressive as they expected. So what we can do now, we can stop taking images there. We can go back to our mount software, and we can, let's find another comet. Now then, what I've discovered here, I've also got Sky Safari on here. So 2017 T2 Panstarrs. Hopefully we can see that one, we'll have a look. 2017 T2 Panstarrs. I'm using different bits of planetarium software for different things. 2017 T2 Panstarrs, there it is. So let's do an OK on that. Oof. Where are we going now then? So the scope's moving again. I need to check that we can see through the slot in the dome, the shutter. And I think the answer is yes. Didn't move very far. So let's have a look now. So we'll do the same thing as before. We need to go to, I get the right thing going. Yeah. I'll go to the guide scope first of all, make sure it gets an image. 5 seconds, let's just have a see. This is just testing that it produces, it can see something. So we've actually just gone a little higher in the sky, not too far from where Y4 Atlas was. I think we've taken an image there, yeah, it must be there, yeah. So now we'll go to our plate solving, just to make sure we can get the image into onto the camera CCD sensor. Off we go again, starting taking an image, starting a solver. As we sync different objects with the telescope, it should get more accurate each time. He says, hopefully. So we'll see what it's doing now. So it's okay, so the target accuracy was not met, so it's doing another process. Not quite there. It's always interesting to see whether or not you can spot the object you're looking for in the guide camera. Of course, the guide camera's generally got a much wider field of view because you've got it on a shorter focal length telescope. So the guide scope is only, I think, about 152mm focal length. So you get a much wider field of view than you do on the main telescope, which has a longer focal length. So the main telescope here is 952mm focal length, so almost a meter. And so only 152 mils for the guide scope. And of course, the size of the sensor also makes a difference to what field of view you get. So you have a large sensor, you can have generally you can have a large field of view. A small sensor, you only get a small field of view. Right, okay, we're back in again. So we'll jump straight back over to ATIK Infinity software. I'm afraid we're going to have to get rid of that one. So we'll reset that and we'll take a fresh image now. So that image on screen is still of Y4 Atlas. And now we're looking for T2 Panstarrs. So we're taking a 30-second exposure. See the little green bar at the top, just about to finish. Presumably that there is, so this is T2 Panstarrs. So we're stacking again, so let's just see what happens after we stack a few images. Because you can see the tail is this direction, I think. Once again, lots of stars in the background, but of course we've got lots of noise as well, of course. You see the background turn darker then, as the stacking does some of its work. So the speckle in the background slowly disappears. Never totally. Of course, the better the camera, the better the scope, generally the better the image. It's interesting because the comet head looks very bright, and it's next to looks like it's next to a star, or there's a star there as well. So what I want to do, I'm going to go back to Stellarium a minute. Well, it might be easier doing this way. Sky Safari works quite well. So there's Sky Safari. Let's zoom in on here. Okay, so there's a star. Assuming this is the correct direction for it in the sky, there's a star just away from the head of the comet. So we go back to our image again. So it should be just below it. Yeah, that's right. Yeah, so there's a star in that, and here's the comet's head. Once again, another. That is quite a bright comet. We'll leave this going again for a while. So according to Sky Safari, this is in Camelopardis. We can pronounce it correctly. I never can. Although I just call it the giraffe. So here we are. Once again, another planetarium program. This is quite a nice one because you can easily create observing lists of various objects. I decided to do one of comets just for tonight, of course. This is actually in magnitude order, so brightness order. So in actual fact, there's a very bright comet at the moment, and it's called Comet C2020 F8 Swan. Unfortunately, you can only see it in the southern hemisphere. Rather a pity, really. So the next one in brightness after that is T2 Panstarrs, what I'm looking at now, and then Y4 Atlas, all the bits of Y4 Atlas. Quite interesting, that all Y4 Atlas ones. And then we've got other comets to look at afterwards. So we'll have a look at some of these other ones in a bit. So that's Panstarrs. So we zoom out a bit more, we can see where it is in the sky. So we're in the north part of the sky. So here's the pole star, so it's quite close to the pole star really. So this is always, at the moment, although it is moving across the sky slowly, remember, it's always visible at night because it's within the axis of rotation here. I've got the lines here shown as equatorial as opposed to, sorry, as opposed to the zenith rather than the pole star. I can find things in the sky easier that way. All right, back to our image again. See how we're doing. There we are. So this is C2017 T2 Panstarrs. So Atlas and Panstarrs are actually comet spotting systems. So generally comets are named after the thing or person that found them. So of course you have the Shoemaker-Levy comet and things like Halley's comet, that kind of thing. But you also have systems looking for comets. So quite often they're named after the system. And they're given a year, and then the actual Y4 or T2 is to do with at what point in the year it was found. They're all numbered or sequenced, presumably like A1 to start with. So again, this is looking quite good. So I'm up to now 360 seconds. That's about the same exposure, length exposure as Y4 Atlas. It's a lot brighter, I think, than the Y4 Atlas. However, because Y4 Atlas broke up into 5 parts, I suppose really the brightness has been split into 5 fractions. So rather than all being in one place, it's now spread around a bit more. Tail isn't showing up quite as well as it did on Y4 Atlas. Every comet's different. So basically that's a 7-minute exposure. Yeah. Again, that's pretty good. Okay, we'll stop that and we'll save the image. Save it as C2017 T2 Panstarrs. I think it's spelled like that. Who knows? I'll spell it like that. They'll do me. Save that. T2 Panstarrs. Done. Okay. So we've saved the image. So now we'll go back. Try and find another one now. So what we looked at before, we looked at Sky Safari. So this has got the next brightest comet in the list currently is 210P Christiansen. So let's look for that. First of all, let's get that going. 210P Christiansen. So we go here, sync that. So you want to look for 210. There it is, P Christiansen. Okay, that. Now I think that's a Taurus. I'm not sure we're going to be able to see that now. We'll have a look. Go to. Oh, no, I don't think we could. All right. I was thinking it was Taurus. And before Orion would have gone by now. So we'll cancel that in a minute. That's a pity. Just for information, let's go back to Sky Safari a minute. So we've got 210P Christiansen. So we had comets with that kind of naming system. And then we've got these. Now these are periodic comets. So there's a number followed by a P to mean periodic. And then presumably the finder. So this is the 210th periodic comet found by a guy called Christiansen. 1P is Halley's Comet, because that was the first one that was discovered to be periodic. They're still finding periodic comets. So, right, so that's the next one down is this one then that's hopefully is Cassiopeia. Cassiopeia's always up. So we want C2018 N2 Assassin. C2018 N2. So we go back to our software again for the mount. C /20. I've forgotten what number it was already. 2018 N2. 2018 N2 Assassin. Once again, Assassin is one of these comet finding systems. So they said this is in Cassiopeia. Cassiopeia is always observable. I need to move my dome. That doesn't sound good, does it? Oh, sugar. I just found out what that was. Oh dear. I just caught. This has happened before. Oh dear. I caught the rope on the telescope as it was moving around then. So that sort of didn't help very much, that did it? No, it didn't. Let's have a see. Where it got to. Right. Let's try go to again. So we'd take an image with guide scope. And the guide scope see out. That's a big question. Try again. Just do another capture there. Same. Right, okay. Let's go to plate solving. Capture and solve. So again, we're using plate solving now. So it's taking an image. It's now going to try and match that to the coordinates it wanted. After it's done some plate solving. A long way off because, of course, I had a problem with the scope. I don't know what's happened there. I'm stopping the scope. I'm going to try and park it for a minute. Yes, I think what happened there was because it caught on the rope, it's unset itself quite a bit. So let's just see if we can get this sorted again. Okay. I think that's about right. Okay. So just unpark it. We'll try and find assassin again. So let's do a go to again. Sheesh, it's a bit low. Right, okay, so see if we can see anything. Right. Right, let's give that a go. So first things first, let's have a quick. Oh, what's it doing now? I'm quiet at the moment because I'm not too sure what it's up to. Let's see. Oh, right, that's probably why. I'll see where. Let's go here a minute. I suppose it's quite low to the horizon. It says target is within limits, so let's have a look then. So back to this. Try a new image and see what happens. So now we're trying to find N2 Assassin. Oops. Multitask. So we're just about to come up to our first exposure. That didn't show me anything. No, it's stacking. Let's turn stacking off because no reset. Try again. Okay, here we are. So now we're looking for a comet on here. Looks like we've got an open star cluster in the middle. Not quite what I was looking for. So for N2 Assassin. So see, that's a big, it's got a star cluster in the middle here. Let's have a see if this gives any clues as to what we should be seeing on here. So N2 Assassin. So there's a star cluster over here. Let's go back to oops. Back to our Infinity software. I can't really see anything on there yet. Well, hopefully you can hear me again now as well. I think the battery's just run out on my AirPods. Let's have a see the software. Yes, you can hear me. Good. Back to this one again. I'm not spotting a comet on there anywhere at the moment. I know we're getting fainter and fainter as we go down the list. And spot nothing at all, what it looks like. Comet. What we might do is give that one up. Can't see it. Where are we on? Yeah, there's that. There's trying to find into the assassin. This is an interesting one. We've got the Y1 Atlas in Cepheus, so C2019 Y1 Atlas. And this is, once again, there's a pole star. This is near Y4 again, but it's not actually Y4 because Y4 was just moved to one of the Y4 ones. No, it's not Y4. My apologies. Y1 Atlas. So let's try this then. So let's go back to telescope mount software. We want to go to C2019 Y1 Atlas. Okay, that. I'm going to go to there instead. See what happens. So this is in Cepheus now, it says. So that's right, it's in Cepheus. Of course, the pole star. Not quite further down, so the scope up in the bottom of the head again. A little bit. Back to our software again. Pi. So let's take another image through that. Oops. Chrome. So here we are. So now we're looking for Y1 Atlas. We're going to do the first image of the guide scope, and now we'll go through the light solving. Second iteration. Hmm, 46 arc seconds away, not quite close enough. Okay, we've got the green light, so let's come back to our software. Okay, so it's not stacking. I think you can see where it is, can't I? Need to move the scope slightly. Not quite accurate. So what I need to do, Get a finder mode. Right. If you go back to the next, press a button, so it's This is in finder mode, but it looks a bit weird now, doesn't it? I think it might be this area here. So we need to centered. Okay. Let's see what happens. Yes. Okay, so here we are now with Y1 Atlas. So let's start stacking, shall we? So this is another comet that was found in 2019. Assuming the Y1 was found just before Y4. One interesting point here, we have a pixel down here that looks like it's like an on pixel, looks like it's bright blue. We do get pixels on sensors that are sometimes always on. This is what dark frames remove from exposures. Basically, a dark frame means you take a picture without any light coming into it. The only things that should show are things that are broken, and that looks like a broken pixel. You can only tell because they're either red, green or blue. So once again, this is quite a nice image coming along with Y1 Atlas. The head of the comet isn't quite as bright as the previous one. You still got the greenish glow around the front of the head. That seems to be the tail in that direction. So I've stacked 6 images, so that's 3 minutes so far. I was just waiting for it to explore similar amount of time as the other examples. And that's what you're seeing from Sky Survey. There are always many comets around to observe. In this case, the white as opposed to the grey are the ones that should be available for viewing. I think because I generally do this early in this evening, that's why the one has gone in view. Charles Messier, who came up with this famous list of 110 objects not to look at, because he was a comet hunter and he didn't want to look at things or find things that already we knew about that weren't comets. Because there are a lot, as we now just discovered, there are lots of comets around in the sky. Recently there's been one interstellar comet, Borisov. I think that's too far away, too faint for my view to see. But again, another interesting observation there. Okay, what we'll do, we'll stop taking images. I'll save this one. Once again, let's find out what it was called. So again, we have this one. Oops. What I'll do again. Okay, so this is a 2019 Y1. So let's save this. C2019 Y1. C2019 Y1. Okay, let's save that one. Done. Okay. I think what we'll do is we'll call that It's been going over an hour. Well, that's it for the evening. What I'm doing. So here we are. So back to me. So we'll say that's it for the evening. We'll be back at some point in the near future. Not sure what I'll look at yet. Once again, if you have any things you want to see, just send me a comment. Thank you very much, and good night.